Combal, and thank you for joining our session on Earth observation to protect planet and people at this year's EU Green Week 2020. Our session will feature panelists from some of the most preeminent and active organizations throughout the Commission or throughout the EU dedicated in some way to biodiversity protection. We have representatives from the IUCN, UN Environmental Program, ECMWF's Copernicus Climate Change Service, the Global Land Service of Copernicus, as well as representatives from the Commission itself, DG Environment, DG RTD, and the JRC, Joint Research Center. Biodiversity has become an increasingly salient topic in public discourse, and it faces new and different challenges. To address this, policymakers have increasingly turned to geospatial information, Earth observation, satellite and in situ data to inform their decision-making processes and make evidence-based policymaking decisions. Our panelists will describe the science and the tools that they produce and contribute to this particular field. We will explore their contributions in two different segments. So our session, which is about an hour long, will be set up into two parts. The first being presentations which focus on science to support policy. And then we'll have a brief Q&A section where you, the audience, are invited to propose questions to our audience. We've also collected questions from social media over the past few weeks, and we'll bring those up as well. In the second half of our session, we will focus on tools and platforms that our organizations have created to make geospatial information more accessible to new and different audiences. Our first presentation comes from a representative of the Copernicus Global Land Service and European Commission's Joint Research Center, Great Maenhout. Great, the floor is yours.
Thank you, Aaron, and good morning, everybody. I think you definitely have heard already during this week about Copernicus, probably in more than one session. Our aim would be that we give you a kind of an overview of what and how we, with this Copernicus program and with Earth observation data in general, can provide more information on environmental progress. And we would like to give you as well a flavor of the future of the Copernicus program in the current context of the European Green Deal and Europe's digital agenda. Now, Copernicus is called as well EU's eyes on Earth. And in fact, it started with the aspiration of the EU member states already more than 2 decades ago for global monitoring for environment and security. And that with a longer term perspective of Earth observation data that need to come in. And so there are committees and there is as well a user fora, and we carefully think about what series of satellites we need to have to provide data that is useful for as well our citizens as well as our policy makers. We want to have reliable data that are as well there covering a longer time period without gaps. And so therefore we have now these 6 series, and you see that more satellites are coming in to keep the data trend time series covered. Now the data is as well fully free and open, so you can download it as a user. And it is as well user-driven. So we do look at the feedback of users and the needs of users and policymakers to look for the further evolution of this program. Now, Copernicus is more than purely the satellites. Definitely we look at Earth observation data as well as measured in situ data. That is our basis, our observed evidence of certain variables. Now we do have as well services around it so that this data can be as well translated in some knowledge that are needed. And we have 6 services at the moment. That is the Marine Service, the Atmosphere Service, the Emergency Service, Security Service, a Land Service, and last but not least, the Climate Service. We do provide with that as well some generic data and some data that can then further be used in applications downstream. And that is then further developed in the industry. So that is not done at Copernicus level. That we leave to the Copernicus economy of European industries that can further digest information and provide applications for the users. And we do look at user uptake to make sure that our program remains agile, of interest for the users. Now, what is a type of information that you can expect from the services? I take here the example of the Global Land service. You can have from there, for instance, indicator data sets for our sustainable development goals. We have sustainable development goal for food and nutrition security. We have as well water-related ecosystems, where we look at the surface water extent and how this is varying over time, so the very dynamic time series. We can look at the UN Habitat to the urban build-up, and translate that in population living at certain places, and so the growth of urban areas. And for then number 15, for the biosphere, we have as well land productivity dynamics, which is serving another SDG indicator data set for the Food and Agriculture Organization, for FAO. This information is, of course, of generic value. Now, you would ask me definitely what is in for biodiversity. What can we see there? We don't see butterflies from space. No, what we see is reflected light, but with that we can derive information on the cover of the color of the land cover. And we have here an image taken on the 2017 of and we see here how this land cover has been changing. With aerial photography, you see that this corresponds really to deforestation. This is happening in a natural park, so we rather don't mention the name and the place. We do know that in Africa you find a huge amount of biodiversity. In fact, it's the source of our biodiversity. Now, I did have here two pictures, but with the animation that is gone, you see here the tree loss with red dots and the recovery with green dots. And you see that there are more red dots than green dots in the period from 1990 to 2000. Now, underneath here was another image that has the same setup, where you see this, that it is even becoming more red in the period from 2000 to 2010. Now, we go as well more in detail, and we go, for instance, to this area here. We look at natural parks like Great Limpopo, and we do look at what are stresses there, how can we as well come to better information on the land cover, what are the real changes, and that we do with very different detailed information on the different classes of the land cover, and from that we derive land use and changes in the land use as well. Now, to anticipate, you might be still a little bit suspective that you see only things on large scale. So what would be in when we have some measures like lockdown measures in the post-COVID-19 situation? So what impact can be seen? Now, there has been several publications. I take here one example, that is here the impact of the lockdown on the Venice Lagoon. And you do see a transparency that changed, that is measured in situ. You see from space the turbidity that also changed with the lockdown. Now, I don't want to give here any information on whether this is good or bad for our environment. That is not as evident. We have, of course, as well seen that illegal activities were not stopping with the lockdown measures. So also illegal logging, even in Europe, has been continuing. And we ask you as well to think about the illegal dumping that you might have been seeing around. So in a nutshell, what we need is to share this observation-based information and really to share with you Earth observation capabilities. And we do see an enhanced uptake of Earth observation, but we think it can still be done more. There has been a scan of new technologies, methods and tools that can provide further advice on the Copernicus program and guide further research there. And we will work with that further in this Earth Observation Knowledge Center to make sure that, that our program remains really state of the art. Last but not least, we think with the huge amount of information that is coming available and more partners in that game as well, coordination is important, and we need to have this as well done across different disciplines, which can be a challenge, bridging different communities. But definitely, last but not least, information is our best defense, and knowledge needs to flow to the right people at the right time. And with that, I would like to give the floor to our next speaker, Bruno. He might give you some more examples, like as it was already anticipated, on illegal activities. Thank you.
So let me make a very brief presentation based on a concrete example of what is our vision at DG Environment for the use of Earth observation for nature protection. So for the legal context, let me consider two of our directives, the Birds and Habitats directives that are meant to protect birds and other animals, species, plants, and habitats. Under these directives, member states have to designate the so-called Natura 2000 sites, which are meant to ensure sufficient protection of the species and habitats and improve their conservation status. So member states have a reporting obligation of the account, conservation status, and trend of the species and habitat at national level, which is mostly based on in-situ surveys and reported every 6 days. So you will find the result in this state of nature report. The need for monitoring nature will very likely increase in the future, for example, with the biodiversity strategy that you already know, that is targeting to increase the proportion of protected areas, the monitoring of restoration targets, the increase of diversity in agricultural areas, the mapping and protection of carbon-rich habitats, you name it. So very clearly, there is a need for monitoring, which is linked to our legal framework. And the requirement, the need is increasing with the need for more exhaustive, up-to-date information as a proxy for conservation status. Now, the Copernicus program and its Sentinel constellation are certainly a real breakthrough in that respect. In particular, Sentinel-1 and Sentinel-2 for what concerns nature protection, because they are giving access to real-time series of multispectral, high-resolution, up to 10 meters information. Now, another important breakthrough is the availability nowadays of big data, cloud computing capacity, which are absolutely needed to process this huge amount of data. So, with such technological breakthrough, at DG Env, we are willing to develop a series of Earth observation-based products in line with the directive and our strategy, as I explained in the beginning. So you will find more details in the link I put on the slide. So we are currently working on the Copernicus for Natura 2000 COP4 and 2K projects, which is meant to develop an automated system to monitor on a yearly basis land cover changes in Natura 2000 sites. And in this project, we will pay more attention to grasslands. In particular, we'll try to detect grasslands intensification related activities, such as mowing, plowing, etc., and also abandonments, since the two situations correspond to a loss of biodiversity. So the time series of changes will start in 1992, which is the beginning of the Habitat Directive, and it will be based mostly on Landsat and spots, and replaced by Sentinel-2 and Sentinel-1 time series after 2016. So much better quality. So the overall information will be made publicly available through websites as a environmental compliance promotion tool, and to encourage its use, reuse, and appropriation in other projects. One key element is that the generated information will allow to access both European scale, so visualizing what we call hotspots of changes in European regions. So here I show you a mock-up of the public website. And we will be able to zoom down to Natura 2000 sites to visualize the evolution of land covers in the sites, as well as grassland gains and losses and the related activities. So to conclude from this framework and example, this project is trying to explore the potential offered by Sentinel and Copernicus. And if successful, we will certainly try to extend this kind of experience and building of information to other type of habitats. So that's something we will consider in the near future. But there is another very important point beside technology. There is, we will want to engage with the community working on nature protection in the countries and in other DGs. In particular, to encourage the adoption of remote sensing-based approaches, but also to get feedback from practitioners and ensure that the definition of the product we will put in place really reflect the actual needs of those communities. So the ultimate goal is to develop tools and practices common to the communities working on the implementation of the Nature Directive. So that's it for my presentation. I leave the floor to the next presenter.
Thank you. So hello everyone. I'm Gilles Ollier from DG Research Innovation, head of the sector on environmental observation, and I would like to briefly highlight the role of research and innovation in the domain of in the way it contributes to the protection of the planet. First and foremost, I would like to remind that the Green Deal, which has been issued by the European Commission, is a key policy driver put forward by the Commission to protect the planet and people. And in the context of this Green Deal, environmental Earth observation is key. For instance, for the monitoring and citizen information in the domain of decarbonization and depollution, in the domain of efficient use of resources and crop and food prediction for sustainable agriculture. It's also crucial data for the global inventories and assessment to support halting biodiversity loss. Ocean Arctic mapping is also the environmental observation and Earth observation is very important for ocean Arctic mapping in support of the blue economy. And this is also crucial data for resource identification and exploitation condition for renewable energy. And so research and innovation in this context is key because it's very important to bring together Earth observation and research and innovation together. And I would like to say that the Commission is making utmost effort in this domain, with at least 35% of the future Horizon Europe funding to be dedicated to climate solution. We also have just recently issued the Green Deal call for 1 billion euro under Horizon 2020. We have under Horizon Europe putting forward 4 Green Deal missions on climate adaptation, oceans, cities and soil. And several European partnerships will also be supported under Horizon Europe, very relevant to the topic of this session. So coming back on the Green Deal call, I would like to mention that it is an effort that support the activities or the actions in the domain of people and planet protection. And as a matter of fact, many topics of the Green Deal call are in the domain of Earth observation and use of Earth observation. For instance, for forest fire, there is a topic also on European research innovation capacities and services, on climate services, ocean modeling, and citizen observatories. An example of one topic under the Green Deal call is developing end-user products and services for stakeholders to support climate adaptation and mitigation. This is obviously going to build, those solutions are going to build on the Global Earth Observation System of Systems, on the Copernicus Services, on ESA capacity, and the idea is to cover the last mile in the downstream part of the value chain to deliver services and products usable by citizen government for adaptation and mitigation. Looking into the future, basically most relevant to Earth observation research is the area of intervention space within Horizon Europe Cluster 4, Digital Industry and Space, and the area of intervention on environmental observation in Horizon Europe Cluster 6, Food, Bioeconomy, Natural Resources, Agriculture and Environment. The space research under Horizon Europe will enable supporting the evolution, upgrade of the technologies and services currently delivered through the Copernicus program. And the environmental observation part of Horizon Europe will cover research and innovation activities addressing supporting specifically sustainability and protection of the environment. Looking a little bit into the future and more specifically at Cluster 6 of Horizon Europe on food, bioeconomy, natural resources, agriculture and environment, we have four main strands foreseen. One is on delivering climate services. Another one is on better accessible and exploitable environmental knowledge. There is also the very important target to filling in situ observation gaps, making good use of a wealth of environmental data acquired by the citizen. Here, the citizen involvement is very important. And at the end, the use of environmental observation to detect the impact of environmental changes on economic and societal sectors such as transport sector and energy. I would like to remind you that beside the Copernicus program, we are involved at international level in the Commission to address global challenge through the GEO initiative, the Group on Earth Observation. And it is, of course, GEO is benefiting a lot of Copernicus, but also from many projects under the Research Framework Program, and is addressing the Sendai Framework, the SDGs, and the Paris Agreement. The European component of GEO is EuroGeo, and it is also a research-oriented initiative, very connected with Earth observation, and in particular to act as an incubator in cooperation with Copernicus, also to deliver integrated European contribution to the Group on Earth Observation, but in compliance with the GEO engagement strategy, support the implementation of the Agenda 2030 for Sustainable Development. I hope I gave you a quick overview of Earth observation and research, and should give the floor to the next speaker.
Thank you very much, Gilles. And yeah, so following on from these presentations, I just wanted to take a moment to reflect on where we are right now in terms of climate. So this graphic shows the last 2,000 years of temperature and where we are right now. So we're currently living in a 1.1 degree warmer world. And you can see through this archive of the last 2,000 years, and much of this data is actually recorded in biological archives, so things like tree rings, corals, ice cores, that kind of thing. And one of the striking components of this graphic is that the rate of change that we've seen over the last 30, 40 years is faster than biodiversity has had to deal with in the recent past. And I've had some animations that haven't quite worked out. But anyway, the impact of this slide was that ultimately climate change impacts all elements of society and all elements of policy. So we can't deliver the Sustainable Development Goals unless we understand the climate risk and the climate exposure to these individual goals and plan accordingly to mitigate these climate impacts. So what is the Copernicus Climate Change Service? We heard from Greet in the beginning about the Copernicus Services, and really the role of the Climate Change Service is to take climate data and turn it into information. So the way we do this is we use observations, primarily Earth observations from satellites, but from all different types of sources around the world. We standardize and simplify this data and collate it in the climate data store. This is all free and open access and fully transparent and traceable. And this information is relevant in a way to enable users, whether they come from the policy sector, from the private sector, or from society, to understand our past climate, our present climate, and our future climate, and therefore plan accordingly. So how to understand the climate system? There's currently 54 different indicators that are defined by GCOS, and these indicators are made up by different components of the Earth system. So we have chemical, physical, and biological parameters in the atmosphere, in the ocean, on the land surface, through the water cycle, so in the cryosphere and the hydrosphere, and of course the biosphere as well, and all the feedbacks that occur within this. Currently within the Copernicus Climate Change Service and the Climate Data Store, we have 22 of these 54 essential climate variables available. And obviously we don't do this in isolation, but we have a huge community of collaborators that work with us to deliver this. And then the primary use of these climate indicators is to put them into products that understand our climate, whether it's past, present, or future. So by far and away the most popular product that C3S provides to citizens is what's called reanalysis. So our reanalysis product is effectively a hindcast of the climate that we've all lived through over the past years. So reanalysis is it takes a state-of-the-art weather model and it combines it with millions of observations and assimilates that data. And what this enables us to do is to effectively create a map without gaps. So in areas of the world that are very data poor, such as Africa, South America, and the rest of the developing world, through reanalysis, it really enables us to interpolate between known observations to understand the climate parameters like temperature, like precipitation, like wind that have occurred there in the past. I'll just give you a snapshot of some of the examples that we have. So this is one example that has been done in partnership with Vito, where it looks at the future of ecosystems in Europe. This particular example is looking at oak ecosystem, and it looks at the suitability of oak ecosystems, looking at a middle of the road future scenario for carbon emissions. So you can see on the graphic here, it's looking at the far future, so around 2080 to 2100, and the implications for oak forest from a temperature and precipitation perspective in Europe. The next example that I wanted to share is looking at all these different types of bioclimatic indicators can get remarkably complex. And this is an example where we worked with the government in Costa Rica and local universities there. And we use something called Holdridge life zones, where elevation becomes a critical component to understand how humidity will change with elevation, what implications this has for protected areas, to ensure that there are biological corridors established to future-proof these protected areas through time. And the last example, which was supposed to be a lovely animation, was looking at the migration pathway of a particular bird, the white stork, where it has its wintering grounds in Africa, but it comes to Europe in the summer to feed. And this annual movement correlates really well with the vegetative index. And this is one of the challenges that we face when we're trying to future-proof protected areas, is understanding whether the triggers that cause the birds to migrate in the first place, whether that's coincident with what they need at the location that they're going to. So in this example, birds obviously need trees to be in leaf, and then the subsequent insects to be at peak, caterpillar production or something like that, so that the birds have plenty of nutrient sources. So just to sum up, there's so many opportunities to use Earth observation data, and we've learned so much about the opportunities associated with the Green Deal. I just wanted to touch upon 4 examples here. So obviously, we've got great opportunities to assess the climate suitability of Natura 2000 sites in the future, looking at urban green infrastructure and the climate adaptation mission board. There's lots of opportunities to use C3S data to ensure city adaptation and resilience. And then, of course, we've heard a lot this week about nature climate solutions. So we can look at the bioclimatic indicators to understand how which ecosystems can draw down carbon more effectively, and how we restore and protect those ecosystems to achieve that ecosystem service. And finally, another example is really understanding the risk of future extreme events, what implications they have not only for biodiversity but for society as well. So thank you very much.
Samantha, my sincere apologies for my background comments. Fortunately, we have a very professional panelists that will be presenting for us. In regards to time, we're running a little bit behind schedule, so we're going to move forward from this Q&A and hold our questions till the end. We have received a few questions already from the audience. If we don't get back to you in this session itself, we'll get back to you by email from one of the panelists. Next up, in view of time, we're going to move on to a presentation on a tool and a platform by Alan Bellward from the European Commission's Joint Research Center. Alan, the floor is yours.
Thank you very much, Erin. So the title of this is No Water, No Life, and it doesn't get any more basic than that when you think about biodiversity. But if you're going to make any sort of sensible or sustainable decisions about that pretty basic thing, you need some pretty basic information, like where is it? And there you have a series of challenges. The first one is, which bit of the water are you looking at? And from a biodiversity perspective, the bit that sits on the land surface is probably one of the most fundamental. It's binary. What lives in and on surface water doesn't live in and on terrestrial environments. So knowing where it is absolute. And there's your first challenge. There isn't very much of it. There's less than 1 in 1,000 liters of our wonderful hydrosphere, of our blue planet, that actually sit on the surface. And then you have the second problem, that what is there moves. It moves over time, whether you're talking about a season or whether you're talking about years. So lakes contract and expand, and rivers migrate, and wetlands come and go, and we even create new ones ourselves when we flood fields for agriculture. So you've got to look for a very little amount, and you've got to look everywhere, and you've got to look all the time if you're going to map it. And that's where Earth observation comes in. And working with the Google Earth Engine team, we threw thousands of years of computer time and millions of satellite images that have been collected over 35 years to build up a comprehensive set of maps of surface water that include time. These are completely unique perspective on this massively important biodiversity source. It doesn't just tell you where it is, it tells you when it was there as well. And because of that, that's been made available to the science community now for for 3 or 4 years now through the Global Surface Water Explorer. And it was also adopted by UN Environment as the reference for SDG 6.6.1 on freshwater ecosystems. So you'd have thought we could have, that's pretty much it. We've done the mapping, we've put it out there, we've made the data set available. But this year, we've gone old school and we've produced a book, this thing here. And a book, you might say, well, why on earth would you do that in a digital age? But a book is a different communication mechanism. It's a different tool. It's actually quite difficult to ignore something that's that size and that weighs almost a kilo. And it has an alternative lobbying thing. And the other thing about a book is it's there as a permanent reference, and it's very easy to dip in and go backwards and forwards in the story. So what the book does is it starts off by actually explaining the importance of surface water for the climate system, for biodiversity, for energy, for health. It then goes on to explain in detail why you map it, what you use maps for, how you map it, what the physics of remote sensing is, what the systems are that you can use. And then it presents the global picture, and it shows where the 80,000 square kilometers of what used to be lakes and rivers have disappeared. They've gone. 80,000 square kilometers. That's a lot of land. And at the same time, where the 184,000 square kilometers of new lakes have appeared. As a species, we just love flooding land, it seems. Then it goes into a whole series of regional studies, and so it covers things like real in-depth biodiversity hotspots like the Pantanal, where we've seen all the problems with the fires in this, what is essentially a wetland ecosystem, but it burns, and that's been the big issue this year. And it even covers the sort of human dimension, like here, where it's a mixture of a biodiversity loss, where a protected area actually was turned into a hydroelectric dam, and then that dam burst and killed over 70 people. And that sort of process is captured forever in the book, thanks to Earth observation. And so we have produced a book. It's old school, but you can't ignore books. It's based on facts. It's based on refereed and published science. It's there as a different communication tool. It's there as a different way of getting messages across. And in common with the digital formats, it's freely available, and all the details are on the slide there. So thank you.
Very much, Alan, for your presentation. Next, we move to Alberto Arroyo Schnell from the floor is yours.
Yes, I think it will be myself. This is Alberto Arroyo from the International Union for Conservation of Nature, and I will try to keep it short for the sake of time. I'm going to present you the results of a specific project that I think can be very helpful in this context, because it's going to introduce a new variable, the law, the legislation. And actually, I think that it has been mentioned a number of times before that the Green Deal is upcoming now, and is going to need all the Earth observations, all the tools, actually not only Earth observation, but any tool to help for its implementation. And let's remember that one of the key challenges for the achievement of the biodiversity goals in the past has been the implementation and enforcement of existing very good legislation. So anything that can help in that direction is going to be very welcome. And therefore, this tool that I'm going to present to you now is, we think, something that can be very interesting. This is the result from the Environlens project. It's a Horizon 2020 innovation project that is combining components from the corporate and the legal sectors with the Earth observation-based services, Copernicus, that has been mentioned a number of times. It has been coordinated by GeoVille, with a number of partners, Synergize, the Aristotle University of Thessaloniki, the Artificial Intelligence Laboratory, ourselves in the International Union for Conservation of Nature, and DLA Paper. So a very varied number of actors helping to put together a tool that can be very helpful. We have worked in a number of cases, 6 cases in Montenegro, Albania, Armenia, some others, and the main result is what we call the eLINS portal, that I'm going to mention in a while. Before that, just very quickly to mention that this is an innovative project, as I said, and it has been recently recognized by innoradar.eu. It was assessed by the GRC as having high level of market creation potential. So we are happy that the project is actually creating some interesting results already. Now, in terms of the tool, this is, as I said, the eLINS portal is still not available. It will be available soon, and it has 3 functions at the moment available. One of them is the exploration tool, which is what you can see in front of you now. So we have simply the possibility to have different Earth observation in different moments in time. And if you move that black line that you see there in that black bar to the left or to the right, you will see how the land use, the landscape has changed. And this is a very quick way of understanding rapidly how the changes in the landscape have happened. Now, what you see here is actually one of our cases. It's our case in Albania, and there you see, it's maybe not that easy to see, but close to the river, in the riverbank, on the right riverbank, you can see some urbanization that has been developed. This is only in the course of 2 years, what you see in front of you. The next function that is already available also in this environment as eLens portal is the legislative discovery. Here, what you can do is select an area, for example, how we did here, this blue rectangle, and you will see that every piece of legislation, environmental legislation applying to this area will appear on the column on the left. I insist that this is just an example for now. It just shows you the potential. It's really very powerful. When you have all this legislation in a complete list close to the area, that can be very helpful, thinking all the time in implementation and enforcement. And finally, the third element, the third function that is already available also is the so-called monitoring and alert function. Here you select an area which you wish to follow. You select what exactly you would like to track. This is what we call services. You see here on the right, burnt area detection, for example, illegal mining activities, deforestation detection. And what you will do is that you will receive alerts should there be any changes of that nature in your area of interest. Again, a very powerful tool for environmental legislation implementation. So just to conclude some final ideas, first of all, I was mentioning that the eLens portal is still under development. We expect to have a final version ready for internal use already this month. And then the portal will be first applied for the 6 use cases that I mentioned. After this will mean that there will be some fine-tuning before we are being able to launch it for external use. So to conclude, as I said at the beginning, implementation has been one of the key challenges, and it's also identified as one of the key challenges for the future. So we have very great ambitions with all the strategies that we have. We have all this powerful legislation. Now for the Green Deal implementation, we need everything that we have in our hands to ensure that the implementation works better. So tools like this can be very, very important and necessary, I would say, for the achievement of the environmental goals, such as the Green Deal. This is the way forward, and therefore this final slide, the green path to the future. Thank you.
Much, Alberto, for your presentation on EnviroLens. Last up, we have a presentation from the United Nations Environmental Program, Mike Harfoot, who is a senior scientist there. And Mike, the floor is yours.
Thank you, Aaron. Hello, everyone, and thanks for the opportunity to present some thoughts and findings from work that UNEP WCMC has conducted into the role of Earth observation for global conservation efforts. And I want to kick off my talk by just reiterating or rather clarifying that I'll be focusing my attention on the role of Earth observation for informing about the state of biodiversity and the drivers of biodiversity change. And also to reiterate what we mean by biodiversity here, which is typically or classically the variety and often also the amount of both living organisms, so incorporating their genetic composition, their taxonomic identity, as in what species they are, and their functional traits, but also often the variety of ecosystems in which they live, or the properties of the ecosystems. And Earth observation is currently capable of observing structural aspects of ecosystems and definitely certain traits of plants within those ecosystems. But it's not, as previous speakers have pointed out, it's not currently possible to observe whole ecological communities or the variation of within those communities. And it's also not trivial to establish relationships between the variables that can be observed, such as those reflecting ecosystem structure, like tree cover, or indeed those plant functional traits. It's hard to relate those to the diversity of other organisms in an ecosystem. Simply put, tree cover does not equal biodiversity. And that's because the relationships between some of those variables and biodiversity vary considerably between ecosystem types and for plants with similar trait values because of evolutionary or biogeographic processes, and also because of human impacts, which might change those relationships. So, for example, in a paper we published earlier this year, led by Elizabeth Green, we showed that observed tree cover changes were generally poor at predicting changes in the populations of organisms, even though those organisms were selected because they were dependent upon forest habitats. And those relationships didn't show up because there were other effects happening which were affecting the populations, which we couldn't observe from space. However, that's not to downplay remote sensing. To be clear, and Earth observation is incredibly powerful for observing some of the major drivers of biodiversity change. For example, habitat loss, which we've already heard about, and given the example here of the Global Forest Watch program, or indeed in the oceans for observing fishing activities, one of the major drivers of biodiversity change in the oceans. And we've been working, for example, with Global Forest Watch to understand what the biodiversity implications might be of the forest loss that they're showing up in their remote sensing. Earth observation, as previous speakers have also said, is increasingly recognised as critically important for decision makers, and that's for several reasons. So the broad spatial coverage which it presents, combined with its increasing spatial resolution, mean it can be used as a default data for reporting progress towards environmental targets, as is the case for the Sustainable Development Goals. And it can also be used in its global sense or in its broader sense because it provides a consistent data set for allowing comparison between national progress against targets and goals. So in a previous ESA-funded project on Earth observation for Sustainable Development Goals, we identified, at least for targets 14 and 15, those related to life on land and below the water, that there were 9 indicators at that stage for which Earth observation data were particularly relevant for, and 6 of those it was highly relevant. And recently, the Convention on Biological Diversity has made formal calls for stronger links between the Convention and the parties to that Convention and CEOS, the Committee on Earth Observation Satellites, and the Global Earth Observation Biodiversity Observation Network. And of course, the update frequency of Earth observation mean that it's really powerful for monitoring impacts and progress. And the combination of that spatial and temporal characteristics mean that Earth observation is well suited to be used by decision makers to understand where biodiversity is likely to be now, what the major current drivers of change are, and what the effects of the decisions that they're making are, what the impacts of policy decisions, for example, are. And I illustrate that with work that we carried out under an Horizon 2020 project called Eco-Potential, which explored how Earth observation could be used to inform protected area management and decision making by generating a suite of indicators on ecosystem structure, structural properties like fragmentation, or ecological variables like pest population dynamics or species distributions. So to move on to challenges for Earth observation. So I think there's a consistent challenge about the capacity for some countries, organizations, or decision makers to work with Earth observation data. And that could result from the lack of capacity, lack of computational statistical infrastructures to analyze the data, or a lack of technical ability and knowledge of what the state of the art is. I think it's important to recognize that there can be issues of acceptability of the data, of using Earth observation data for legally binding national reporting. For example, under the Convention on Biological Diversity, parties sometimes have concerns about using data that's not being collected by their scientists or systems. And I think in part this reflects concerns about accuracy, transparency, and the demonstrable usefulness of Earth observation data. Another challenge is that for many aspects of biodiversity, there's still this really critical requirement for field-based data on which to formulate models that can be applied to the Earth observation data so that we can generate the required indicators. And the collection of this field data may quite possibly, in my view, become rate limiting, especially if we need sufficient data to robustly demonstrate the accuracy of the products that we're making to make them useful for national governments, etc. So I think there's an onus on expanding field observational data sets as we develop Earth observation capacity. And in recent work we carried out on another ESA project called the Global Diversity Project, looking at trying to generate new, open and reproducible essential biodiversity variables. We considered what sort of barriers there were to the use of Earth observation, and came up with feedback from consultation exercises that there was a terminological barrier between Earth observation scientists and conservation practitioners and decision makers. And I think some kind of terminological roadmap to try and make collaboration easier could be a useful sort of tangible tool to do there. And I think there's also a barrier in terms of the scope of possibilities of Earth observation. So I think the conversations between the satellite engineers or the sensor engineers and people working in biodiversity science and conservation science are not happening. And so the sensors being planned for the next 10 years might not be filling that critical gap that we think we're going to need, or at least we know we're going to need. And then lastly, in terms of future developments, some of which are underway to a greater or lesser extent, but I think obviously the widespread use of Earth observation for operational monitoring of activities and policy decisions, using it for reporting on progress and for enforcing breaches to regulations, that's going to be a critical next step. I think the integration of Earth observations with ecological modelling approaches is going to drive more accurate projections of current and future biodiversity patterns. So we've been working on a NASA-funded project designing approaches to use Earth observation to monitor both projections of the drivers of change, but also to constrain biodiversity models individually and collectively. I think we're already seeing a move towards actually more direct remote sensing of biodiversity itself. So NASA's new JEDI system is up and running, and we're using data from that to look at vegetation structure at almost the individual tree level. And the forthcoming SBG mission will provide unprecedented hyperspectral information that's really getting to some of the diversity of at least plant traits within a given footprint. But my last point is, I think for this to happen, for us to generate really powerful and useful Earth observation products, then we need investments in this collaboration between scientists, decision makers, and conservation practitioners to address some of the disciplinary barriers I talked about earlier, and to make these the products that we generate as useful as possible. And with that, I will say many thanks for your attention.
Thank you very much, Mike. We'll now move into the Q&A section. Our Q&A is going to be a bit short today, so I encourage everyone visiting this session to follow the organizations on their websites and social media accounts to see the good work that they do every day and follow their developments as they progress. We have a few questions already from our audience. The first I'll read out loud and I'll field to our panelists. We have been concerned with multinational companies related with eucalyptus plantations operating in European countries in large scale with harmful practices, such as damaging operations and herbicides. Land with such plantations has been increasing. How can this be solved? I'd like to field this first to Alberto from the IUCN. Maybe you can expand a little bit on the EnviroLens tool, but I invite all of our panelists, of course, to share their perspective on this question.
Thank you very much, Aaron. Of course, it's a difficult question, and I can't say that I have the solution. I wish I would. But what is for sure is that these are the kind of issues that need to be solved with the implementation, a better implementation in future. The Earth observation system that we were proposing with EnviroLens can definitely be helpful in identifying this quickly and seeing which kind of legislation is being breached, if any. This is a starting point. I think I think the Commission and the national authorities will be the ones to have to take decisions.
That's perfect, and you're right. It's there's different ways of using this tool, and it's going to be useful for not just people that are monitoring these areas, but also the areas themselves to improve their practices. I have another question from the audience. As Copernicus keeps an eye on Earth, its seas and oceans can predict an ice collapse in the Arctic and Antarctic seas, so that it makes possible to catch these rock falling ice and to store this fresh water rather than evoke world ocean level rise. So I think the question they're really asking is, can we capture this ice that's falling in the ocean so that it doesn't increase the sea level rise, but rather is used for freshwater resources? Samantha, I think as the representative of the ECMWF and Copernicus Climate Change Service, can you share your thoughts on this question?
Well, thanks, Aaron. And it's a really interesting question. I think one of the challenges is obviously where glaciers are. They're often really remote locations globally. And also, although our Earth observation is coverage of the planet is excellent, often the passes over a particular place on the planet are only every 2 or 3 days. So I think it'd be really challenging to be able to predict where these glaciers are going to carve off and be in place with a vessel and the appropriate equipment in a very safe way to capture the carved icebergs. I think what we can do and what we have seen this year in particular, we've seen a lot of heat waves in the Arctic, particularly in the Siberian quarter of the Arctic. So by carefully monitoring the climate, we have the ability to inform the implications of these heat waves. And we've seen this in the Siberian Arctic with implications for permafrost melting, for infrastructure collapse because of the permafrost melt and things like that.
Very much, Samantha, for sharing that. We are running a little late on time. We have some more questions from the audience, but again, to our audience members that have proposed questions, we'll try and get back to you through email. Right now, though, I'd like to hand the floor to Great to wrap up our session and give a quick shout out and thank you to our panelists and all those involved in the creation of this session.
Thank you, Aaron. So I think we have seen that Earth observation is definitely, and Copernicus in particular, is definitely having an increasing uptake and therefore an increasing importance. There are, of course, as well quite a lot of challenges. There are, of course, limitations to the Earth observation data. There are as well difficulties with how to communicate some an inconvenient truth from time to time, in particular when it goes about environmental non-compliance. I think I'm very happy to see that there has been more than 100 people following this session. I see that there is really interest. I definitely invite everybody to consult the Copernicus website as well as the information given during the presentations. We have also initiatives like GEO that definitely you can follow online. And we will be further open to your questions and replying that by email. I would like at the end to thank in particular our policy DGs for being there, for giving also their view. So in particular, Bruno Combal from DG Environment and Gilles Ollier from the GRTD. I would like to thank as well our international partners, so ECMWF with Samantha for the Copernicus Climate Service, but as well IUCN, Alberto, Chanel and Micah Harfoot from UNEP. I think it's very important to have these international organizations taking care of global conservation in the way they can and making use of all data, also Earth observation data that is for hand. I would like to thank as well the technical support behind the screens. This was a great support team that we had there. And last but not least, my thanks to the colleagues, in particular Alan. He has been, I think, 30 years experience in this field. Great talk and great book that he made. I can only advise you to really look into the book and read that what is of your interest. And in particular, Aaron, my colleague, who has been really working hard for putting this whole session together, for moderating that, and for having us here all sharing the view on Earth observation and its usefulness for environment and for biodiversity. Thank you very much, and see you in maybe next sessions.